A galvanic cell is also known as a voltaic cell, which involves a spontaneous redox reaction that generates electrical energy. To understand how a redox reaction occurs in a galvanic cell, let us start with a simple cell that is readily made in the laboratory. A galvanic cell consists of two electrolyte solutions that are separated from each other by a salt bridge that allows the flows of ions, in which each end are plugged with a glass wool. The salt bridge is filled with a salt solution that takes no part in the electrode reaction, such as KCl solution. The anode half cell is a zinc bar which is placed in zinc sulfate solution. The cathode half cell is a copper bar placed in copper sulfate solution. At this combination, it is called a Daniell cell. Both half cells are joined by a circuit which consists of an external wire, a voltmeter, and a bulb. What is the reaction occurs at anode? Since zinc atom is more electropositive than copper atom, zinc has higher tendency to release electron. Zinc electrodes dissolves and produce zinc 2+ ions and release 2 electrons. This reaction is called oxidation. The zinc 2+ ions enter the zinc sulfate solution. As the reaction continues, the excess of zinc 2+ ions are built up in the zinc sulfate solution. The number of positive and negative charge in anode half cell becomes imbalanced. Therefore, the negative chloride ions migrate from the salt bridge to the zinc sulfate solution and maintain the neutrality of the solution. Now, let us trace the flow of electric current through the cell. At the zinc anode, zinc atoms are oxidized to zinc 2+ ions and release electrons. This electrode, which pumps electrons into the external circuit, is marked as the negative terminal of the cell. Electrons generated at the anode move through the external circuit to the copper cathode. The electric current flows from the anode to the cathode because there is a difference in electrical potential energy between the electrodes. The difference in electrical potential between the anode and the cathode is measured by a voltmeter. The voltmeter reading is called cell voltage, or also known as electromotive force. The readings are recorded in unit of volt. The cell voltage for this Daniell cell is positive 1.10 volt. If the salt bridge is removed from the half cell, the circuit is broken and the cell voltage becomes 0.00 volt. At the cathode, copper 2+ ions from copper sulfate solution accept electrons. Copper 2+ ions are reduced to copper atoms and deposited on the copper electrodes. This reaction is called reduction. The copper electrode, which pulls electrons from the external circuit, is considered to be the positive terminal of the cell. As the reaction proceeds, the region around the copper electrode tends to become deficient in positive ions as copper 2+ ions are consumed. To maintain the neutrality, the positive sodium ions migrate from the salt bridge to the copper sulfate solution.